Today we're solving problem 22 from the Amc 10A from 2020. For how many positive integers n is less than or equal to 1000 is the floor of 998 over n plus the floor of 999 plus over n plus the floor of 1000 over n not divisible by 3. Recall that the floor of n is the greatest integer less than or equal to x. Okay. So we have this function and it seems pretty intimidating, but let's just put in some values for n. Let's see here, when n is 1, is this divisible by 3? Well, when you actually put n in and add all these up, this is kind of a tough case because we want all the ones that's not divisible by 3. So if I say this doesn't work, then that means it is divisible by 3. And when you add these up, this is actually divisible by 3. So it's not gonna work in our case for like our answers. So how about 2? When we put 2 in, this is gonna be 500. This is, well, 1000 divided by 2 is 500. 999 divided by 2 is like 499-ish point something. But it's the floor, so this is 499. And we can keep on doing that. Well, when we actually sum all these up, this is actually not divisible. So it works. Not divisible. And then try 3. Well, when we try 3, we plug all these values in, take the floor of all of them. In the end, we get that this answer is yes. For 4, this is going to be a real pain. Well, not a real pain, it's just going to take a long time to evaluate this. 1000 divided by 4, 250. 249 and 249. This is also not divisible by 3. 5. Also not divisible by 3, because when you actually plug n is equal to 5, it's not divisible by 3. But now, when we get to a 6, it's no again. Well, what do we see here? Well, 1 does not work, but 2, 3, 4, 5 works. Is there any specific factors or anything about 2, 3, 4, and 5? Well, there actually might be. So 6 is a no. Well, 6 is a no, but all these are yeses. And that means that this sum n, like, it doesn't have to be an integer, but as long as it divides into some number, point something, we get rid of the point. All these yeses, they actually signify something. 2, 3, 4, and 5, but not 6. Let's take 1000. 1000 can be divisible by 2, 4, 5, but not 6. 99 can be divisible by 3, but not 6, or 1, but not 6. One's kind of confusing. So in the end, we realized that all the working numbers for n have to be they have to be able to divide into 999 or 1000 evenly. Well, what is 999 in prime factorization? 999 is 9 squared. This is 3 cubed because there's a 27 times 37 to the first power. Then 1000, this is going to be equal to 10 cubed or 2 cubed times 5 cubed. Now we can use the number of ways to find a factor. This is 4 times 2, this is 8. 4 times 2 is 8. And then 4 times 4 is 16. Now there's this one special case. This 999 has 8 factors, 1000 has 16 factors. But we have to subtract one that does not work, this 1. So 8 minus 1 is 7. 16 minus 1 is 15. So our sum is going to be 15 plus 7. This is going to be 22. And we are done.